1968. That's the year Windhoek, Namibia solved a problem that the developed world is still arguing about. The city began turning sewage into drinking water, not as a pilot, not as an emergency backup, but as a permanent solution. Faced with drought and failing groundwater supplies, Windhoek had two choices. It could either innovate or it could ration forever. So, built a system, wrote the safety rules as it went, and for more than 55 years, it has supplied up to 35% of the city's drinking water, with zero documented health incidents. This isn't some future technology. It's a solution we've had for decades and largely chosen to ignore. I am Reese Tisdall, and this is The Future of Water, in which we talk about all the ways which companies, utilities, and people are addressing the challenges and opportunities in water. This is episode 135. That's a 135, and I got a pretty good feeling it's going to be a great one. That's because it's not only is it 2026 and a new year with new perspectives, new ideas, and new insights, but more importantly, I'm going to be joined by my Bluefield Research colleague, Maria Cardinal out of Spain. And she's just authored what I think, in all sincerity, is a super interesting analysis and report on energy optimization for the water sector. Today's conversation is not only going to be grounded in the new global analysis from the Bluefield team on water and wastewater utilities, but the core finding is that energy is really no longer secondary operating costs. It's really one of the biggest levers utilities have to reduce risk, control costs, and depending where you are in the world, and I think we'll talk to Maria about it, cutting emissions. Where does that matter and why does it matter? But before we get to Maria, you're going to have to bear with me just a little bit longer. What caught my eye this past week is, and maybe it was even over the holidays, so I don't want to get away from this or forget it. There's been a little bit of time, but Jacobs moved to acquire the remaining stake in PA Consulting. It's not just what seems to be a cleanup transaction. It's also a signal about where large engineering firms are seeing value. And this is a question that's come up among a number of clients and other people in the industry. But by fully owning PA Consulting, Jacobs really is doubling down on not only its higher margin advisory, digital, and AI-enabled services that can be increasingly integrated into its core engineering platform, but it seems that the logic is to move earlier in the client decision cycles, stay involved across the full asset lifecycle, and steadily lift group margins through a mix rather than just scale alone. But what are some of the key takeaways? Well, PA, like I said, it does operate at higher margins than Jacobs' traditional engineering business, and full ownership does lift Jacobs' EBITDA margins to, I think, if I recall, looking at the press release, was about 14.5% on a pro forma basis. So with limited reliance on cost synergies, the real upside comes from shifting more work towards advisory and digital services. It'd be interesting to see how this plays out. Also, like I said, Jacobs is buying earlier access to capital decisions. And this is something that a number of engineering firms have been talking about. How do they get more into I would say, not just program management, but really helping the cities, towns, utilities make their decisions from cradle to grave. So full ownership, once again, you capture more value, allows Jacobs to further integrate PA strategy, innovation, transformation directly into its engineering delivery. Then lastly, the move sharpens Jacobs' position against its peers, paying roughly $1.6 billion for the remaining stake. That values PA at about 13 times EBITDA and reflects what seems like a premium for strategic control and long-term optionality. So Jacobs is seemingly intentionally blurring the line between a traditional engineering firm with global advisory and digital consultancy, responding to the same forces that's pushing other peers towards higher end and more resilient consulting-led growth. And Would say a big question throughout all of this is not only just understanding the whole process or life cycle, like I said, but also the role of AI and how it's going to apply to not only engineering decisions and utility decisions, but also the design as well. And we've seen a number of different deals that have happened over the last month or so, like I maybe even mentioned it on a previous episode, was WSP acquired TRC recently. It's also been looking at AECOM as a consideration in the past, and as well as other engineering firms as well. So I think there's definitely more consolidation and restructuring, and I'd say streamlining across the engineering space. And so I look forward to seeing how that happens and where it happens and actually who does it. So, with that being said, let's get to Maria Cardinal from Barcelona, Spain, and talk a little bit about energy optimization and what that means. All right, so I'm joined here by Maria Cardinal. Maria, what's up? Happy New Year.
Hi, Happy New Year, Reese. I think it's the last day we can say that at time of recording it.
I don't know. I don't remember when I was talking to someone about that, and maybe it was Dave McGimsey. We were talking about that as well. Some people say to the end of the month. In any case, this is the first episode, number 135 of the new year for the Future Water podcast. So I'm sticking with it. I'm cool with saying Happy New Year. But with that being said, right before the 2025 and the year came to a close, you had been working to the very end to get what is now an energy optimization report out, which I think is super interesting. It's on water, wastewater utilities, and maybe that goes without being said. But at a high level, it really does show that energy as a whole is one of the more strategic levers that utilities have at their fingertips, maybe to manage risk or control costs. And you're in Europe, you're in Barcelona, to address emissions, carbon emissions are related to that. So before we dive in, can we just talk a little bit about what prompted the analysis? Why are we talking about it? And maybe even what you found most surprising about it as you looked globally at different case studies and projects, et cetera?
Indeed. So I guess that going a little bit by order, what prompted this report was, well, we have a Europe office now, and we monitor very closely what is going on in the water sector here. And of course, energy, especially in the last few years, has become a very prominent factor when it comes to operational expenses across different industries. And of course, for water and wastewater networks and plants, this is a key piece of the pie, when it comes to OPEX. So seeing the impact of the pandemic, then the conflict with Russia, and other maybe smaller scale crises like power shutdown in Spain and so on, really brought energy to the forefront. So I think that's why that's like to name a few of the reasons that we thought an energy report would be interesting for our readers. And just to give you some global numbers to approach the extent of the importance of electricity in the water sector, is that a global demand for electricity in the water sector is projected to increase a lot in the next few years, in the next few decades. So by 2040, electricity use globally in the sector is projected to reach between 4 to 8% of global electricity demand. To give you an idea in a more local regional level, energy consumption for just the municipal water sector accounts for more or less 45% of total energy costs within the municipality. That is a lot. That is nearly half. And when it comes within the water sector, water supply and wastewater treatment processes account for 75% of this energy consumed within the municipal water sector. So we're talking about very big figures. When it comes to OPEX in any given utility, this range varies greatly. So we have energy representing in between 10 to 40% of utility OpEx. But overall, it's still always among the top 3 operating costs for water and wastewater utilities. And while it's an inescapable cost to some extent, it's one of the more flexible or malleable expenses that utilities incur, because compared to other categories like labor, utilities can modify the amount of energy they use, how much it costs, depending on, for instance, the source of energy they use, or if they can also produce it on the plant itself. So there are a lot of things that you can do with energy, basically. And when it comes to one of the things that surprised me the most about this report was that even though I knew that pumping took a lot of energy, pumping is in fact the largest energy consumer within water and wastewater networks. Of course, this comes hand in hand with aging infrastructure, oversized pumps, and so on. No, but pumping, just moving the water from one place to another or through treatment processes, takes on a vast amounts of energy.
Yeah, and I think I agree with you. I mean, if you sort of step back and we're looking at the water sector all the time, and you kind of think, well, the pumping makes sense. Moving water or wastewater, moving all of that is very energy intensive. I do think, yeah, I think your point early on is sort of like it does vary regionally as well. You know, energy costs because of, let's say, Russia, Ukraine are high. Germany in particular, but other European countries are tinkering. I don't know if tinkering is probably putting it lightly, but changing their fuel mix for electricity supplies. And I think the key about pumping is these are they're operating assets, and so are pumps being more are there changes being made to how efficient they are, whether it be time of day operations, doing different things that are getting smarter. Let's talk a little bit about, like, what are the 3 most important focus areas for energy optimization for water, wastewater utilities that you guys looked at? Because I know there was a lot of debate about how to frame this entire analysis. So can you give me the 3 top items on your list?
Definitely. The top 3 items for us at the end of the day were, as we were talking before, pump optimization, that had to be in there. It's a key piece of the pie here. It's a part of the main puzzle. Why? Because pumping is the largest source of electricity demand in water systems. In drinking water systems, it can account up to even 80% of total energy consumption. And we see that data optimization can typically deliver between 15 to 30% energy savings in just a few months. The second one that we wanted to focus on was aeration and process optimization. This is in relation to different treatment plants. So that would be both drinking water and desalination plants on that end of the water cycle, and also wastewater treatment plants. And the main reason for this is that, particularly for wastewater treatment plants, this is very important. And again, this links once more to the carbon emissions aspect that we also commented on earlier. Aeration accounts for up to 60% of total plant energy use for wastewater. So indeed, optimizing how blowers function, using variable speed drives and so on, can definitely improve the efficiency of aeration technologies, and can routinely achieve between 15 to 40% energy savings just by reducing over aeration and helping to stabilize the oxygen levels within that part of the treatment process. And so pump optimization, aeration, and other process optimization processes. And the third one would be load shifting and demand response. This is very closely tied with pump optimization and process optimization, because it's about shifting the operations of the pumps or treatment processes to off-peak hours, and that can deliver very quickly with minimal capex quite a substantial amount of savings, considering that payback is within like 1 to 3 months, and you can reach up to like 15% savings just by changing when you operate. Of course, these three aspects of, or these three solutions of energy management are not the only ones. We could also be talking about leakage management, as well as more in-depth analysis on like biological, chemical, and like other physical treatment processes, such as like dosing. And on top of all of that, aside from, let's say, the actual infrastructure, we could also implement solar panels so that there's renewable energy integration and even on-site production linked to other digital solutions, so that the overall energy costs are further reduced. But to make report that is a little bit more focused, and targeted, those are like the three main pillars.
Yeah, no, I think it's super interesting. So, say pump optimization, like you said, aeration and process optimization, and then load shifting. So, the numbers you're putting out there are significant savings, right? And I think in your point about leakage, we talked about this before, and we didn't look at leakage because the focus on leakage traditionally, if I understand this correctly, has been more focused on supply rather than on energy usage, correct? And so therefore, that was a determination we made, at least at the time, right?
Indeed, that's correct.
Yeah, so I think it's super interesting. And then but a lot of these, I can only imagine the combination of more efficient pumps, like you said, load shifting, the role of AI. I can only imagine that whether it be the OEMs, they start incorporating new technologies, new softwares that will become easier. Then it'll just only take time, right? And I think that's the question: how much time do people have? We've talked a bit about energy prices in different parts of the world. Maybe that's kind of leads to my next question, and that is where you've looked at this globally, you've looked at a number of case studies and references around the world and a variety of different markets. Where is adoption happening fastest for energy optimization, or what's your geographically, where should people be looking at least immediately, and where maybe are things rolling out a bit slower?
So that is a very good question, and it depends on how you're looking at things, in terms of for which, for instance, treatment plant are you looking at. But overall, and I'll come to that in a minute, but overall, I'd say that Europe is leading in terms of adoption. We also said earlier that operational expenditures for energy account for in between 10 to 40% of total OPEX for any, like a typical utility. That is still a wide range. That is because it's about between like 10 to 13% in North America versus 20% typically in Europe, and up to 40% elsewhere, such as in the Middle East and the Asia Pacific region. When it comes to Europe, I'd say that the main driver is just regulations. We have the Urban Wastewater Treatment Directive that mandates energy audits every 4 years now. And in fact, by 2045, all medium to large plants across the EU must source 100% of their energy from renewables produced on site. And part of that is also reducing or optimizing how they consume energy. On top of that, there's also this standard on control and automation that specifies some general requirements for instrumentation, process control, and automation systems within wastewater treatment plants. And so, as you can see, like these results in energy optimization being increasingly compliance-driven rather than just an optional parameter.
Yeah, and I mean, it's always interesting speaking with you and the rest of the Europe team. I mean, there's just seems to be a bigger focus, and I don't know if it's exactly true. Maybe that'll lead to my next question about North America, but it feels like Europe is oftentimes more OpEx focused, particularly in relation to energy. But just because if you fuel mixes and fuel types. Like you said, you kind of look around the world, what percentage does energy make up of the plant? I mean, the other extreme would be if you're an island nation, right? And you're relying heavily on diesel fuel to run your power plants, your energy prices, whether you're in Hawaii or Cuba or the Caribbean, are super high.
Exactly.
And then, so maybe let's talk a little bit about North America. So, how does North America differ from Europe when you're looking at the different regions?
So for North America, again, energy is a top three operational expenditure line, but regulation is more loose in that sense. It's more largely voluntary and it's guidance based. Canada has a stricter rules on it, but overall, it's not as stringent as it is in Europe. So we have seen that adoption is stronger in like large or more digitally mature utilities that often also face like rate pressures or peak energy volatility. But this overall results in that more of a voluntary based uneven uptake of energy efficiency solutions. No, and the implementation of these tools is largely driven by like payback periods in when it's months and not years, and it doesn't require a big like overhaul of their operations.
Yeah, and I suspect it's, if you can pay if the upfront capital costs, and then will it pay back. And then I guess when maybe I'll ask you a question a little bit about sort of what are the opportunities, hardware, software, et cetera. But I mean, while we're talking a little bit about regions in Europe in particular, what role do carbon emissions play? Because we had clients over the years come to us to just better understand. And I think in the US it's changed a little bit. I think part of that is just what's happening in Washington. The focus seems to be less, there's less discussion about carbon emissions, let me put it that way, simply put. But when you're looking at Europe, or I mean, maybe just overall, what role do they play in these decisions? Because I would think that Europe that would just be another underlying driver for focus on energy optimization. Am I correct in saying that?
Yeah, it sure is. So we mentioned earlier very high level numbers of like electricity consumption of the water sector. No, for global water supply and distribution, as well as wastewater treatment plants, they account for over 10% of global greenhouse gas emissions, and so this is very significant. Now that this is linked to the increase also in electricity spend that we're going to see over the next few years. And this is due to the ongoing capacity expansion of wastewater treatment plants and the increased coverage of water and wastewater services across the world. Now, as networks expand now and more plants are built, of course, more energy is going to be consumed and more carbon gas emissions will be produced by the water sector. And when it comes to Europe, there is more advanced regulation or push, let's say, to become more like carbon neutral and use energy savings as a way to also incur carbon savings. No, so pumping and aeration dominate electricity use, and cutting on these two key areas that we've highlighted in our report is also one of the fastest ways of reducing emissions as well as costs. No, so it's kind of a win-win. And since energy efficiency standards are linked to carbon emission reductions in Europe, there's definitely an acceleration push towards this.
Yeah, and I think one thing, at least in my notes on in sort of following your lead, is Europe is more top down or mandate driven. Like you said, there's a 100% renewable target for large facilities by 2045, whereas in North America, it's more, I think, as you've said, reputational or strategic, right? It's if anybody's doing it now, it's more a matter of, and it may vary slightly by city. If cities in the US have targets, and we've done some analysis, which ones have cities or large cities, should I say, have, sustainability plans, and does carbon play a role in that? And so what are the source of emissions? And the water, wastewater utilities are not an insignificant share of that. So that makes sense, right? Mandated regions versus reputational or bottom up driven.
Indeed. I mean, of course, if it didn't come with the economic benefits now of also spending less in energy, I think even though regulations are in place, implementation will be harder. But because they come hand in hand, it's way easier as well for utilities to not just take into account the costs now and the reliability of these solutions, but also input the carbon emission factor into the decision-making process of which projects are prioritized and how fast can they be scaled. And I think particularly for top-tier utilities that, of course, manage larger volumes of water and serve more of the share of the population per country, implementing these solutions is particularly interesting.
Yeah. So, and I think to that point, and I alluded to this. So let's talk about we've talked about the markets. We've talked about sort of the size of the problem or opportunity. As far as the solutions, so where's the technology focus? Is it hardware, equipment, software? What are some of the general trends or areas of focus that we're seeing in our analysis?
So I think a key thing to also take into account is that in order to implement energy management measures, you do need a certain level of digital maturity. It doesn't necessarily need to mean that you need AI and a digital twin in order to implement energy efficiency solutions. Not at all. But you do need a working baseline. No. Having said this, the technology focus is shifting more and more from like hardware first to software-led optimization. And this is building on a strong instrumentation base. So hardware enables it, but software delivers the savings and the scale of energy savings. So we could count as like hardware as the foundation, one of the key like enablers of energy management solutions. And here we would put sensors, meters, data loggers, variable feed drives, SCADA upgrades, all these tools as like the basic must-haves. And then we would move further into the software layer where analytics and intelligence tools such as enterprise asset management, plant design and network modeling, operations management, or plant and pump asset monitoring tools, take the lead. And these in turn, going one level, further or higher, these different software solutions would ultimately feed into network and plant optimization solutions, which would embed also energy management systems. And here we would have advanced analytics, or more advanced tools like we mentioned earlier, digital twins, AI, machine learning, or just like complex algorithm control tools to maximize the efficiency and energy saving potential of the plant or the network.
And so, I mean, do we have a sense? I mean, there are serious dollars going to these. Do we have any sense of what the scale is?
For these solutions, global spend reaches about 135 billion US dollars for this is of course for the period of like 2025 to 2030. And we do have also some segments that actually grow at like more than 20% per year. And then this is like AI optimization tools, pump asset monitoring, and some of the top tier like SCADA layers.
Yeah, and I would say what I like how you framed it, right? You've said basically it's gone from a hardware first towards software, but one leads to another. So there is an evolution, whether it be at a global scale or within a utility or a system itself, right? You can't do some of these things, all the bells and whistles without having a hardware foundation, like you said, with sensors, meters, data loggers, et cetera, I think you said. So no, I really like that because I think a number of companies, clients, they're coming to us to kind of figure out, hey, where do we begin? And I think also within the utilities themselves, they need to understand where are they? Are they at the tactical level, strategic level, and even move down that curve within energy optimization itself? It's important.
Yeah, and I think that the case studies that we've profiled, no, in the report also tell that story, of different utilities at different points in the like digital maturity curve that we often talk about at Bluefield, and how they've implemented different types of solutions that have led to really meaningful energy savings.
Yeah, no, I think I agree. I think the case studies are great. And that's a big part of it, looking at real life examples of what's happening. So maybe this maybe is, kind of my last question regarding this report. And maybe this doesn't need to be asked. Maybe it's obvious, but I think it's important to put it out there. But there are hidden benefits behind all of this, right? That when we were talking with the entire team last week, when you start looking at if systems or equipment is more efficient, one huge benefit would be asset life, right? You can extend the life of certain of capital equipment. So, am I wrong in saying that, or is that a benefit, and are there others?
That I think is one of the main benefits. Second to saving in energy bills, of course. But indeed, like implementing these solutions also automatically, basically, they lead to longer asset life of pumps, blowers, motors, things that are, not a negligible spend for utilities when they acquire them and they install them. So extending the useful life of these assets is key, and not only that, but it also means that they will run for longer at an optimal level. Optimization reduces the run hours, the cycling, throttling, vibration. It also helps uh, keep equipment closer to the best efficiency point, the best operational level they can achieve, which lowers the wear and premature failures. It also leads to fewer breakdowns and reduces the maintenance burden. Firstly, because you can also monitor, without having to be physically, close to the pump, for example. No, so you can, do condition analytics to catch issues early, such as misalignment, cavitation, pump clogging, etc. And so it enables you to see the different variances in terms of output, now of use, and analyze if there are any shifts, and be more proactive rather than reactive to any issues that might appear along the way.
Yeah, I think that's huge. I'm really excited about this, and I think a number of clients are as well. And like I said, from the outset, when you completed the report and the analysis, and you were sharing it all, I think there's some really interesting. One is just the scale of energy usage. Then how does it vary by geography, which is interesting, and then your point about hardware to software evolution. And then in this case, it's like there are also long-term benefits. I mean, we see that in a number of different ways, right? Cities, towns, utilities can extend asset life and maintain, at least defer capital investments. It could be through, in this case, energy optimization. It could be through, treating wastewater for reuse, if you can be more efficient. So I think that's where the water sector, there's a lot of low hanging fruit, it feels like, to capture some of these benefits that ultimately save money. I know it feels like a big pill to swallow at the beginning, because sometimes to make the transition, you do have to invest in certain hardware or software. But if the payback periods, when natural gas prices in Europe are, are they, let's say, if they're $30 MMBTU, 25 to 30, I mean, they're 4 or 5 times higher than they are in the US. Your ROI can come way down in a very short period of time. So I think this is super interesting. With that being said, so now that you've done this, I know this was a huge endeavor and really interesting. And I think anybody who's interested should reach out to you to ask questions and learn more about it. So what's next? What's up within the Europe research team, and what are you working on over the next 3 to 6 months?
Currently, we're working on finalizing the latest Europe policy report, which we also have the US counterpart to it now, of course. And we started doing that last year, and I think we're getting into the groove of how we produce these. And in this edition, we review and analyze the policy developments across Europe that have taken place over the last 6 months or so. And we provide some insights on what to expect in this year, now in 2026. So we are about to publish that, and next on we'll be working on the digital water forecast updates that we're going to implement this year. We are going to review all the forecasts for Europe as well as rest of the world, and the US and Canada. And I'm quite excited because we're also working on how to improve that system. So it's going to be a busy year.
Yeah, and I think also in production, I think, correct me if I'm wrong, isn't it, there's also a PFAS report for Europe coming out.
Yeah, that's true. Yeah, that's one of our colleagues, Zineb. She's working on a PFAS report, and then Antonio is also working on a stormwater report.
Yeah, that's great. So yeah, a lot of content. It always feels good at this time of year. I don't know if anybody recognizes what happens at the end of the year at Bluefield. We're basically living in, and I think I may have said as much, living in 2 different years, right? You're trying to get out of 2025 in this case, and then into 2026. So now we're sort of free, and now it's all upside from here. Trying to, it feels like we have a long runway, which is a good thing, but lots of good content already coming out of the gate. So I look forward to that. So, Maria, thanks a million for jumping on. This is super interesting. We could talk more about this, and I think this report and the analysis is really great. And yeah, I think this is awesome. So, thanks a million for jumping on. Also, relatively last minute, because I know you're busy as well, doing access requests and working with clients, etc. So, thanks a million.
Thank you, Reese, for the opportunity.
All right. Talk soon. Take care. All right. That was really great. Really, I'll say it again. Really interesting analysis that Maria and the team have put together. Appreciate her jumping on. Hopefully, this recording went well. We had a couple technical glitches along the way with internet connection. I'm actually in Berkeley, California, working with the Berkeley team here this past week. So if you're out west, we've got some meetings with clients later today. But if you're on the West Coast and want to meet some Bluefield colleagues in person, they're here. They also want to talk a lot about data, because that's one of the big areas of focus out of this office, in addition to just Western US analysis. And I'll be actually on the red eye tonight back to Boston. And so, but if you need anything, you can always reach out to us at Bluefield Research. Water experts at bluefieldresearch.com. Sorry, I got ahead of myself. And as this is 2026, let's give a shout out to everybody on the Bluefield team that makes this happen. We got Mike Gaylor, we got Ryan Sullivan, got Kelly Talbot, and Steph Aldag. It wouldn't happen without them. They're a big part of this endeavor. 135 episodes, something I think we're all really proud of. We hammer the nail every 2 weeks to provide you and all the listeners content. If you're in Boston, Barcelona, New York, Chicago, San Francisco, that'd be Berkeley in this case, or Paris, reach out to us. That's where we are in person. And if you have ideas for topics, waterexperts@bluefieldresearch.com. We answer all those emails. We'll get back to you as soon as possible. I've been actually talking to a number of different clients more recently. They're asking about podcasts. How do we do it? What do we focus on? We've got a lot of content, and we like doing it. We like sharing it, and we want you to know about it. So this is one of the channels to market, so you can hear our voices and what we're thinking. And this podcast and these water insights have been brought to you by Bluefield Research. To learn more about our work at bluefieldresearch.com. It's a website. Just give it a visit. Interesting. Lots of good stuff. And I think the energy optimization report is at the top of the list. Until next time, be well, be safe, and take care.